Welcome to this explainer. Look, today we are tackling something that is absolutely critical for your success in the Cambridge 9618 Computer Science syllabus. We're going deep into mastering keyboard input in pseudocode. Now, if you're prepping for your AS and A-level exams right now, you already know that pseudocode isn't just about memorizing some arbitrary syntax, it's so much more than that. It's the ultimate proof of your logical thinking. It's how you show the examiner you actually understand how a computer processes information. But here's the reality. There is a massive, and I mean massive gap between just knowing the basic input commands and actually scoring top marks on those complex exam questions. You can't just throw code at the page, you have to design your answer like a master architect. Every single paragraph, every line of pseudocode needs to be a structural masterpiece. So today, we are doing something special. We are completely decoding the official examiner reports. We're extracting the insider intelligence to give you a clear, highly actionable playbook. We're going to transform how you look at these exams. Let's get right into it.
So, I want you to really think about this question for a second. Why do so many incredibly bright, hardworking students lose what should be easy marks on multi-step pseudocode calculations? It is incredibly frustrating not just for the students, but honestly for the examiners grading the papers. Picture this. A candidate understands the underlying theory perfectly. They've done the reading. But the moment they're asked to actually read a keyboard input, process that raw data through a loop, and handle the underlying logic, the marks just completely evaporate. Poof. Gone. Why? Because they treat the answer like a messy brain dump instead of a structured architectural blueprint. Over the next few minutes, we're going to figure out exactly why this happens. We're going to break down the specific traps that catch out even the best students, and more importantly, exactly how you can avoid them to secure those top grades.
Here is our roadmap for today's explainer. First, we'll uncover the pseudocode trap. Then, we'll look at mastering core principles. After that, we'll break down the procedural framework. Next up is critical analysis evaluation. And finally, we will reveal the top examiner warnings.
Section 1. The pseudocode trap, where marks vanish.
Okay, the absolute classic trap that Cambridge examiners see year after year is something we call superficial breadth. Let's imagine a student. We'll call him Alex. Now, Alex works hard. Alex has studied the textbook cover to cover and knows a little bit about everything. He overloads his answers with raw computer science facts, just throwing every term he can think of onto the page. But here's the problem. Alex lacks real analytical depth. When you're dealing with pseudocode, it's never just about knowing how to write a simple input statement. You might know the keyword, sure, but if you fail to build the complex logical structure required to actually validate and process that data, those facts are useless. Cambridge isn't assessing your ability to memorize a dictionary of terms. They are strictly assessing your analytical depth. They want to see how you piece the puzzle together. If your reasoning isn't logically sound, clear, and deeply structured, you simply won't get the marks no matter how many buzzwords you write down.
Moving on to Section 2, Mastering Core Principles, Building the Foundation.
I want you to pay very close attention to this. The principal examiner reports explicitly state, and I'm quoting directly here, candidates referencing cross-topic connections achieve significantly higher marks. This right here, this is an incredible insider secret. The theoretical architecture of pseudocode doesn't exist in a vacuum. Top-performing candidates understand that when they take a keyboard input, it connects to everything else. It connects to the exact data types being used, it connects to array manipulation, it connects heavily to validation routines. To get the highest marks, your conceptual understanding must be fully, 100% connected across the entire syllabus. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now, because mastering these connections is exactly what we help you do. You have to stop viewing the syllabus as isolated bullet points and start seeing the overarching framework.
Which brings us nicely to Section 3, the procedural framework, step-by-step success.
So, how do we actually apply that deep thinking? Well, true algorithmic thinking requires 4 essential, non-negotiable phases. Think of this as the foundation of your architectural build. First, step-by-step decomposition. This means taking a massive, overwhelming exam question and breaking it down into tiny, manageable input and processing steps. What exactly is the user typing in? Second, appropriate data structure selection. You need to consciously decide where that keyboard input is going. Is it being stored in a single, temporary variable, or does it need to be appended to a massive 1D array? Third, efficient code implementation. This is where you actually write out the pseudocode logic, making sure your loops and conditionals are tight and accurate. And finally, rigorous testing. You absolutely must mentally trace your code. Walk through it in your head. If the user types a 5, what happens to line 3? You simply cannot skip a single one of these steps if you want top marks.
Now let's translate those 4 phases into a standardized 5-step sequence for the actual exam hall. Let's imagine another student, Sam. Sam is super smart, but under the pressure of the clock, Sam rushes and completely misses the command word requirements. To avoid Sam's fate, you follow this exact sequence. 1. Deconstruct the question. What is the command word actually asking you to do? 2. Extract the relevant data. Pull the specific constraints directly from the scenario. 3. Select your analytical framework. Plan the structure of your logic before writing. 4. Execute with perfectly clear notation. Don't let sloppy handwriting or vague variable names cost you points. And 5. Present your final answer with official Cambridge terminology. Following this exact 5-step sequence is like having a cheat code. It leaves literally 0 marks on the table. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's dive into Section 4, Critical Analysis Evaluation, Thinking Like a Top Candidate.
Let's be real for a second. There is a massive fundamental difference between superficial code generation and true evaluative thinking. Superficial generation is when you just panic and write down the very first input statement that pops into your head, hoping the examiner gives you a pity point. That's what average candidates do. Evaluative thinking? That's what top-tier candidates do. It means stepping back and analyzing time complexity. Asking yourself, is this nested loop going to take way too long to process 1,000 keyboard inputs? It means checking space complexity. Do I really need a massive 2D array here, or could a simple counter variable do the job? And crucially, it means rigorously testing edge cases. Top-scoring candidates constantly consider these trade-offs and justify their design decisions. That is exactly how you start thinking like the person grading your paper.
And when you're asked an evaluation question, say to compare 2 different algorithms, you must hit every single one of these 4 structural points. Think of this as the POEL framework for computer science. Point, evidence, explanation, link. First, you must explicitly identify similarities and differences. Don't just say what's different, acknowledge what they share. Second, you need to use comparative connectives to make your reasoning flow logically from one point to the next. Third, you have to support every single comparison with hard evidence directly from the pseudocode in the question. And finally, you must draw concrete conclusions about their relative importance. Why is algorithm A better than algorithm B in this specific context? If your paragraph hits all 4 of these beats, it is structurally perfect.
Which brings us to our final section, Section 5, Top Examiner Warnings, the Insider Intelligence. Listen up, because these are the top 3 most common pitfalls pulled straight from the examiner reports. This is where dreams of an A-star go to die. Number 1, using the wrong formula or algorithm entirely for the context given. You can't just memorize a sorting algorithm and force it into a question that just wants a simple running total. Number 2, forgetting to check boundary conditions in edge cases. What happens if the system expects a positive integer, but the user types a negative number, or a 0, or even a letter? If you don't validate that keyboard input, your program crashes and your marks vanish. And number 3, providing generic textbook answers. If the scenario is about calculating student grades, do not name your variables X and Y. Name them student score and grade average. Your logic must directly match the exact scenario Cambridge handed you.
But here is a massive relief. I want to introduce you to the method mark strategy. So many students lose easy points simply by giving up or not showing their systematic working. The Cambridge marking framework actively awards method marks for your procedural steps. If you execute your pseudocode logic clearly, if you build that architectural blueprint properly, but you make a tiny, silly calculation error at the very end, guess what? You can still secure the vast majority of the points. The examiner sees your logic is sound. Documenting your step-by-step process, your loops, your variable declarations, that is your ultimate exam safety net. You're getting paid in marks for the process, not just the final output.
So as we wrap up this explainer, I'm leaving you with a challenge. How will you adapt to your next practice paper using these newly discovered examiner insights? Are you going to stop writing generic answers and start focusing on analytical depth over superficial breadth? Will you implement that 5-step framework and explicitly plan for those tricky edge cases before your pen even touches the paper?
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCS, to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCS and click that bell. Don't let another exam pass you by. Take this playbook, build it into your daily study routine, and completely transform how you approach these challenging papers. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.